Hello learners. Today we would be starting with complex numbers and quadratic equations of 11th grade NCERT mathematics. What do you mean by complex numbers? This entire chapter is bifurcated to the first part complex number and the second part quadratic equation. So what exactly are complex numbers? Let's learn with this particular example. So we have x square plus 1 is equal to 0 as an equation. X square plus 1 is a quadratic equation. Yes. Why is it a quadratic equation? The power here, the highest degree of the equation or the highest power of this equation is 2. So therefore, I have x square plus 1 to be called as a quadratic equation. So this equation, if I push plus 1 to the other side, I get x square is equal to minus 1. Now, if I have to remove my square symbol, I have to push that square symbol to the other side. So when I take that square symbol to the other side, my square will get converted to square root symbol. Hope this everybody know. If not, please take a note of it. So x square, any term with a square symbol, if it has to be shifted to the other side, that is either LHS or RHS, the square will be converted to a square root symbol. So I will get x is equal to minus 1 under root. This root of minus 1 is called as an imaginary term. Why is it called as an imaginary term or a number which represents imaginary term? Because whenever I have x square plus 1 is equal to 0, a quadratic equation, roots of a linear equation, quadratic equation can never be an imaginary term or a root with a minus sign. So that in such cases, if I have got the value of x to be any imaginary term, so that comprise or that will tell you that it is a complex number. It will comprise of a complex number. So I have denoted the square root of minus 1 as I, and this I will tell us or it showcases us that it is an imaginary term. So for example, if I have square root of minus 3. So square root of minus 3 can be written as 3 into minus 1. We already know that I in complex numbers is square root of minus 1. So if I substitute root, if I bifurcate basically first, root 3 into root 1, root of minus 1. So we know that root of minus 1 is I. So therefore I get minus root of 3 is equal to root 3I. Similarly, if I have root of minus 5, root of minus 5 can be written as square root of 5 into minus 1. So this can be bifurcated as root 5 into root of minus 1. We already know that root of minus 1 is I. So I will write this as root 5I. So whenever I get complex numbers with I, I will always denote them in which particular part? Imaginary part. So if I is multiplied with any root value or any number for that matter, it becomes an imaginary term. So now, in our lower grades, we have also come across different varieties of numbers. We have come across natural numbers, whole numbers, integers, rational numbers, irrational numbers, correct? So all these numbers, I know natural numbers are the numbers which are countable numbers starting from 1, 2, 3. Similarly, whole numbers are the numbers in which I include a 0 and all rest continues with my countable numbers. Integers, I have to remember my number line. All my positive numbers, negative numbers along with a 0. So I can denote my integers as either positive integers or negative integers. But in my integers, I will also include 0. Okay. So Q is nothing but my rational numbers. Rational number will always be written in the form of P by Q, where Q is not equal to 0. Then I have irrational numbers. So irrational numbers which are non-terminating, non-repeating. Okay, so these terms come under irrational numbers. So for example, root 2, root 3, root 5. So these are all irrational numbers. So all these varieties of numbers, we still have different varieties of numbers like decimals, so and so forth. So all these varieties of numbers come under a certain set called as real numbers. Okay, so any number you categorize, okay, here we are categorizing one below the other, telling they are natural numbers, whole numbers, so and so forth. So if I have to call all these varieties of numbers under one set, then it is called as real numbers. But why did I explain what are different varieties of numbers that come under real numbers for a complex number? Because everything has a link, correct? So if I'm explaining this, then obviously it will have some part to do with complex numbers. Okay, so now I would be explaining that. A complex number is denoted by capital Z. Okay, so this denotion is standard. By Z, you can denote it with any particular alphabet as well. But in standard denotion of writing a complex number is Z. And a complex number is always addition of a real number and an imaginary number. So basically, instead of calling them as real number and imaginary number, we call them as real part and imaginary part. So Z is equal to A plus IB is the standard form of writing or denoting a complex number. Okay, so this part here, I have told you, right? Two parts are there when I write a complex number. One is my real term and the other term is called as my imaginary term. Okay, so rather than telling terms, we are writing them as real part and imaginary part. Here, A is called as my real part. Okay, and B is called as my imaginary part. So whenever I write, I will not include I and tell that it also is an imaginary part. See, we already know that I is iota. If I is there, then only it becomes an imaginary term. Okay. So if we already know that without I, we cannot make an imaginary term. So when I'm bifurcating and writing, there shouldn't be a consideration of I. We already know. So therefore, A is nothing but real part, B is nothing but my imaginary part. So therefore, representing a complex number is of the form Z is equal to A plus IB. So for example, if I would like to give you all an example of a complex number, I can write this as Z is equal to 3 plus 4i. Obviously, this is a complex number. Here I can write A plus IB. Obviously, this also represents my general expression of a complex number. So here A is equal to 3 and B is equal to 4. So therefore, 3 plus 4i becomes my complex numbers. Hope you all have understood. If you haven't understood any part of this video, please pause the video and then get your concepts clear and then only proceed, because concept is our strength. So next we come to different varieties of operations under complex numbers. So in complex numbers, we have addition, subtraction, multiplication and division. Basic 4 operations are there in our complex numbers as well. So for example, if I take Z is equal to 3 plus 2i. Let me take this an example to explain you all how do we go forth about adding a complex number, subtracting a complex number, dividing a complex number and simultaneously multiplying a complex number. So if I consider Z1 as 3 plus 2i, and Z2 as 4 plus 8i. I can add operations on complex number. So I can add these two as how? Z1 plus Z2 is equal to 3 plus 2i plus 4 plus 8i. And one more very important thing is, whenever you are adding a complex number, real part should be added with real part, imaginary part should be added with imaginary part. So how do I write real parts with real parts? So 3 plus 4, next I have 2i plus 8i. So these two terms represent my real part and these two terms represent my imaginary part. So therefore, my final answer for addition becomes 4 plus 3, 7 plus 10i. And one more thing all my learners have to remember, any complex number, you add, you subtract, you divide, any operation you do, your final answer should again resemble the form of a plus ib. Because when you are adding a complex number, the resultant or the answer will also be a complex number. When you're subtracting a complex number, the resultant will be a complex number. So therefore, see, when I just compare it with the general expression, I get this as Z is equal to A plus IB. Obviously, I have in the place of A 7, in the place of IB, I have 10i. So which means my real term is 7 and my imaginary term is 10. So therefore, it is of the form A plus IB. Hope you all have understood addition of two complex numbers. Likewise, we would come to subtraction of complex numbers. The same thing again comes into picture. When you're subtracting two complex numbers, what happens? Again, you will subtract two real numbers, yeah, the real part, and again subtract two imaginary parts of the first two complex numbers, the same thing. We would take the same example and then we would also know how subtraction of complex numbers are done. So subtraction, again Z1 minus Z2 can be written as 3 plus 2i minus of 4 plus 8i. Now what would I do? Whenever I have a minus sign outside, I have to open my bracket. Okay. So when I open the bracket, I get this as 3 plus 2i minus 4. Minus into plus will become minus 8i. Now what will I do? Group my real terms. Real term will always be my numbers, either a positive number or a negative number, but my imaginary number will always be with an I. Okay, so I will group my real terms. I get this as 3 minus 4. Similarly, I will group my imaginary terms. So I have this as 2i minus 8i. So what is, see, I have grouped. So after I group, what do I get? 3 minus 4 will give me minus 1, plus sign in between. Again, 2i minus 8i will give me minus 6i. Again, plus into minus will be minus 6i. Again, this resembles my complex number a plus ib. But in the place of plus, I have minus. So how do I write it in terms of my real part and imaginary part? We know that this resembles a plus ib, but it mandatorily should have a plus sign in between. So if it does not have a plus sign, then how will you bifurcate and write? Only write the terms with a and b. Okay, so I have a is equal to minus 1, I have b is equal to minus 6. So in my previous question, when we added, I think we got both the answers in terms of positive. So everything depends upon our sign. Because I have a minus sign in between, see my answer what I get. It resembles a plus ib, my general expansion, okay? But whenever you write your real term and imaginary terms, please be very careful with them. Since I have a minus 6 in between, I will write my part B. That is what is my part B? My imaginary part with a minus 6. Hope you all understood. Now, before we come to multiplication and division, there is something very, very important that we all have to understand. What is that part? That is nothing but powers of I. So what do you mean by powers of I? Okay, we all know that I is equal to square root of minus 1. What will be I square? I square is nothing but square root of minus 1 the whole square. Correct? Square and square root will get cancelled. I will get I square is equal to minus 1. So in complex number, very importantly, if you know the values of I and I square, any power of I can be substituted and got the values. So very important is your I value and your I square value. So for example, if I have to find out value of I to the power 14, okay, so I to the power 14 can be written as I square whole to the power 7. Here I am using theory of indices. A to the power m into n is equal to A to the power mn. So what do you mean by that? In the place of m I have 2, in the place of n I have 7. So if I multiply 7 and 2, I will get back my previous step, which is 14. See, correct, no? See, whatever you people do, it should always resemble my previous step. If it resembles my previous step, then whatever steps you are doing henceforth is correct. Otherwise, it will be wrong. So therefore, we know the value of I square from my previous step, which is equal to minus 1, and my power is 7. Correct? Now, one more very important thing. If I have a negative value to an even power, value will always be 1. Correct? Minus 1 to an even power. So for example, minus 1 whole to the power 10, you will get it as 1 itself, positive 1 itself. Similarly, minus 1 to an odd power. So if I have minus 1 to an odd power, you will get back minus 1 itself. So for example, minus 1 whole to the power 9, you will get your final answer as minus 1 itself. So if you want, you can subtract and see, you will get back the same result. Okay. So now for proceeding with this particular value, minus 1 whole to the power 7 is equal to minus 1 because you have an odd power. Okay. This can be understood better with, okay, so for example, if I have minus 1 cube, I can write this as minus 1, minus 1, minus 1. We all know the sign convention. Minus into minus will become plus, plus into minus will again become plus. Yes, no? No, it becomes minus. Minus into minus plus, plus into minus will always be minus. People still who have doubts with sign conventions, always whenever you have like signs, you will always end up with the same sign. Okay, plus into plus will always be plus. See, when both the signs are positive, you have positive. When both the signs are negative, again you will have a positive symbol. Okay, when both the signs are the same, you will get back positive. When both the signs are different, you will get back negative as a symbol. So if you remember this sign convention, doing any problem would be very, very, very easy. Hope you learners are understanding whatever I am teaching here. So now, for example, if I have to find out I to the power 60. So I to the power 60 can be written as I to the power 2 whole to the power 30. Correct? So when I multiply 2 and 30, I will get back my previous step, that is I to the power 60. So this can be written as, we all know I square is equal to minus 1. So minus 1 whole to the power 30. And I have already explained it to you a while ago. Any negative term to the power even will always be positive. So this is an even term. Yes, 30 is an even number. So minus 1 whole to the power even will always give me plus 1. So with this, I think we are good to go for multiplication. Similarly, yeah, I will also give you an example of odd powers and then we would proceed with multiplication and division. So for example, if I have I to the power 71. So I to the power 71 can be written as I to the power 2 35. Yes, 35 into 2 will give me 70. Leftover term is I. Correct? Here I am using two properties of indices. One is a to the power m whole to the power n is equal to amn. Yes, and the second one is a to the power m into a to the power n is equal to a to the power m plus n. Now see, how do I proceed with this? You will understand with my next step. I to the power square 35 will become I to the power 70 into this I as it is. Why have I written this I as it is? See, I have an odd power 71. So when I bifurcate the terms, I can write this as I to the power 70 into I to the power 1. So when the bases are same, according to my index, yeah, when the bases are same, powers can be added. So I will get back my previous step. Correct? So therefore, the value of this, I to the power 70. So what do you mean by I to the power 70? So yeah, so I square whole to the power 70. So this is nothing but minus 1 whole to the power 35. Or in other case, if you are finding this difficult, okay, I will just write this as I square as minus 1 whole to the power 35 into I to the power 1. Okay, so minus of 1 whole to the power 35, I have an odd power. So I will get this as minus 1 itself. Minus 1 into I will give me minus I. So the value of I to the power 71 is equal to minus I. Hope you guys are all understanding and finding this video informative. If you are still not able to understand how am I doing all these steps, please pause the video. Please play back the video until and unless you people get a hang of all these concepts, because concept is our strength. If I am not able to do get my concepts right, then it becomes very difficult in my later part. I sign off with this video. We will continue with multiplication and division in my other videos, the next video. Thank you all.